Hello. Hi. Once I've checked the audio, I will see how we're doing. Sounds good. Hello everyone. Welcome to Fable Legends background. Bezier and a chicken. Right, this stream, sorry for the late start. I will actually post about that. Some network issues after reconfiguring it recently for all reasons and broken it. Well, everything was working, but OBS did not like to connect. So turn it all off. Right. Let me just reply to that. Okay. So while the project loads, yes, this is the last stream for this year, and we'll see how it goes. What I want to do for the new year, but we'll talk about that then. Here we go. Yes, so last stream of the year, thinking I'm just going to do some noodling, tinkering around, see what I can do. I haven't really got anything planned for this session, but it did. But something that did occur to me was, as you can probably may have seen from the noticed in the start, in the holding screen in our Apparance video, there's a demo with cables between the buildings, and it occurred to me that maybe that'd be quite cool to have hanging around the ceiling of the these rooms. So I might do that. Build a little fake cable procedure. Not of real catenery. I can do it with, I think I can. Before I just used Bezier with carefully chosen handles. This is also will be a first because it'll be the first generated geometry we're using in Apparance. And then we'll look at how we can decide where to put them and how to attach them and maybe do like chains of them and things. So and multiple them up. So I don't know how far we'll get, but I think I'm just going to play with that. Best way to do that. Well, so the test, we'll build it outside of this environment as a test case. So we'll go and find somewhere to do that. Just maybe over here. I'll need to set up a new entity, which we can set a procedure up for, like so. So I think we're gonna. It's kind of a decorative thing, right? We record. Just make sure everything's running. Yeah, we're all looking good. Okay. Yep. Let's start by setting up the procedure space for it. Right, I'm going to create a new procedure, which has gone in here. Let's call it our decoration category, and this is cable. Right, that is what we're going to do. As usual, I will start with this. So this is where we're going to put it, and this is what it's going to look like. Now we can assign cable decoration. Let's do that. Let's turn it around actually. Typically, so a lot of the procedures work by starting with a frame, and that's drives where everything goes. I think what we'll do is probably just have it so that the cable hangs between top center edges, and maybe try and get it so it hangs to the bottom. That means if you have a short box, it will be a shallow hang. The width won't make any difference, so we'll just leave that narrow for now. But for testing, we'll have a bit bigger. so we can see things a bit better. Right. So that's where we're going to build our cable, sort of hanging under here somewhere. Now you may ask, how do we do that? Okay, so I'm probably just going to noodle around in here for now, and then maybe we can abstract some bits out if we need to make it nicer. So there's some advanced experimental features, still experimental, to do with geometry. So we're going to be using the shape operators today, which is really to do with 2D polygonal shapes. And we're also going to use loft because that allows us to generate geometry of one shape extruded along another shape or path. Shapes and paths could be used interchangeably. So we're going to be doing that. There's a few things I'll need to bear in mind with all of this. All the shape stuff works in the XY only. It just ignores the Z largely. There are some cases where it doesn't. But I think the loft uses 3D. Was it in 3D? I can't remember exactly. But most of this, the shape stuff is flat, and then you have to, and you build it flat, you extrude it flat, and then you have to reorient it and position it into the space that you're actually ending up in. So, for example, it may all appear on its side and things. There might be some fiddling around needed to get it all working, but we'll see how we get on. So the simplest form of this will be we're going to loft. Right, this is quite a complicated operator. Let's merge some things in so we can keep the frame. So that's going to be so we've got shape, which is the cross section, and we've got the path, which is the where it lofts along, and there's loads of other options and capabilities, but we won't necessarily need all of those. And then so we need the shape stuff. Is down here. Shape. So shapes are a list of vertices, which means they're always polygonal, but the shape generation, like if we use ellipse, shape generation operators have controls over how many steps you create, so you can control the sort of quality and detail level. We can probably illustrate. Might be a good idea to illustrate this with just like flat shapes. We can do that first, actually. So let's do that. Wonder if we need to. Okay, we'll come with. We'll try and cope with it as we go. Let's see how we get on. So, because we are working in 2D, you're building these shapes get built in XY. The output, as I said, is a list of vertices, and that for the shape, the cross section, that'll be we want that centered on the path. So because we're basically doing a tube, so it's going to be an ellipse, and it built an XY around the origin. 1 second. Okay. Around the origin. So the frame we're building in is going to be okay. Let's start with. It's going to be. We want so the face frame. Skipping ahead here. The face frame is a unit frame with the lower face, so Z0, because we're building in XY. We don't care about that, and it's centered on the origin. So that'll give us our frame to build our ellipse. By specifying the center being 0.5, 0.5 proportional, that'll always be the center. So again, that's the origin. And we could set that. Let's make that. Let's do it explicitly. So the center is 0, 0. Width. The width. And the reason, actually, let's not do it like that. The reason that's quite handy to have, do it proportionally, is that the width, if you keep the width and height as proportional, you don't have to worry about any of the what the actual size is. It'll always be an ellipse that fills the frame. So that's what we want now. So that will be a circle. We can check that by extruding it. No, we can make a polygon. Polygon. So if we make a polygon out of that and do that, we should. It might be underneath. Hang on. No, it's quite possibly also just not worked. Oh, probably because that's broken. There you go. So that's built us a circle. We're gonna want quite a small circle. So we will want to. Maybe we do need to specify it here because we can't actually. Yeah, let's do that. So we're gonna have a. So that's gone to there for some reason. Why is that? Oh, not notice. Enter. Why? Oh, it's not what we want. This is relative to the frame, so we actually want a face corner frame so that we're building out from the origin. That's what we need. Yeah. And now we can specify if we have. Let's have it as a parameter. Is our thickness. And we're going to make it ranged somehow. And then we can make it bigger. Yeah, so we can specify the size of our cross section. The fact that it's there in the middle is kind of irrelevant. And the fact it's red is just because there's no material. We're just using the polygon operator just to visualize our shape that we're trying to work with. So we've got our small circle. We'll look at the quality thing, the resolution of that later. So that's going to be our shape that we're going to loft. And now we need the path, and the path is going to be our curve. So we're going to need a Bezier curve, which we can also generate and visualize. So let's do that. So we've got a thing called curve, which is Bezier input start, handle 1, handle 2, end, and it's similar to the ellipse. It's built in 2D in XY, and there's a quality level as well. Let me get our list out here. There's some other information like the length as well, which it calculates if we want it. So we're going to. So because this curve is like it's got two ends, it's not a closed shape. You can actually there's an in as well as an out, so you can attach them together, build a longer list. So let's start. Actually, I'm going to start. Let's do it a bit bigger because I'm going to start building like X in XY, and we'll move it around in a bit. So let's do that. Let's do that. So let's just put some values in and see what we get first. We can use the polygon again to visualize the output. And we already have a curve. So the reason we've got a full segment here is because the polygon operator is assuming it needs a closed shape. So it'll just join the two ends together, which is why you get the straight line. But this curve is our... Right, if we do it in the frame, yeah. So the size is so proportion. So we've gone from start at 0, 0 down here, end at 1, 1 here, and the handles are here and here. So you get the curve based on that. And as if we change any of these handles, you can see the fact that it's Bezier and it's a curve. But what we want to do is generate a curve from top two corners and have a sort of hanging underneath. And we can illustrate that a bit with, if we set some of these values to 1, let's move that up to the top. handle, let's do 0.25, 0.75, and then we've got two handles that we can, let's change these values a little bit. So we can move that up and down, and then this one again will move up and down. So we've got control there. Now it's going to be it's not going to be symmetrical. We want to be able to have, I think for most of what we're doing, it's going to be along the ceiling. It'll be from equal heights, so it's going to, each loop is going to be symmetrical. So we'll just deal with that for now. In theory, if we had like different heights, you would hang asymmetrically. So, but we're not going to do that. We're just going to do the simpler case. So we can generate these control points for the inner handles to be symmetrical and have like two control values, and then decide how we're going to calculate those based on the inputs to produce the curve we want. And again, it's going to be an approximation to a catenary, but it should look fine for what we're trying to do. Let's look at that for a minute. We'll come back to the ellipse and the lofting in a bit. I wonder, I might use a box instead of a frame because the frame's a bit thick. No, I can make it shorter for now. Let's do that. I'll do that. There we go. There we go. Do that. Right, so we're going to make these vectors. So let's do float to vector twice. Now they go from Z0. They go. The x is some value in from the left, and on the second point, the handle it's in from the right. So in this case, 1 minus. Are we going to stick with proportion? Probably. I think doing it everything proportionally is probably good, because then the size of that we're building to is irrelevant. The shapes should be the same. So let's go with that for now. Oh yeah, there's options here to how to handle the ends. Right. The handle 1 now has just gone back to 0, 0. What we're going to do is have two values we're going to calculate. I'm going to start by just making them constant and fiddle with and play with. So we'll have a value here from 0 to 1, which is the x here. And we're going to do 1 minus that for the other side. That is that x. And actually what we'll do is for the kind of drop, we'll have 1 minus that for the two y values. So this is the pinch, we'll call it. And this is the drop, we'll call that. We can now, is that correct? Oh, we haven't looked up the handle, there we go. So as we increase the drop, we need 1 there. So now we've got this drop, and we've got this sort of pinch value, which is the bringing the handles in. I haven't visualized the handles, but we can kind of imagine them. And I think it's kind of getting there. We need something like this to probably be. And that's probably good enough for what we want. I don't think it's that critical. Most of the time they'll be hanging fairly shallow, something like that, which looks good. So in this case we've got sort of a light pinch inwards, 0.4 maybe. Let's go with that. And this is the value that we'll probably have a bit more variation on as we generate looser and tighter cables hanging down. So we'll use that shape. Now in theory it should all just scale properly and cope with, yeah, okay. So actually what we talked about having the height drive this drop effectively. So what happens if we set that to 1, and then it's like, yeah, that works. we can control it like that. We don't actually need really just the pinch that is the factor we need. So in actual fact, these are just 0. So we don't use, well, we're not using drop. We'll use the shape of the frame to scale the result. And this is our pinch factor. Okay, so that's generated a curve. We can now, in theory, drive our loft and see what we get. Look at that. We have a loft. We have a tube. We've taken it's got the thickness here. We can adjust for our cable. There's no materials on it yet. And then we've got our hanging loop. Obviously, it's lying on the ground. We can sort that out next. But that is the behavior we want. Let us look at how to get that standing up. So the idea is if it's up here, we want it hanging in the top here. Oh, it's also on the back edge, which is fine for now, but we might want to center that. We'll have a look at that in a minute. So yeah, before we do that, let's give it a material and some color control. We're going different colored cables. So we're going to do, have we got material thing? How are we doing materials already? No, I think we did explicitly. I'm just going to use the default color thing we've got here. So we're show box. Yeah, that just applies material and a color. We can do exactly the same in here. We'll do that here. Material. No, we want it on the loft only. What am I doing? That. The material goes in here. And we get color as well. So we've got material, we've got color. We can bring that out as a parameter. And let's default to black cable. A bit of specular, a bit of lighting going on, a bit specular, but we can obviously now set the color to something if we want a different color cable. Okay, we've got that. So let's get this. I'm going to make it bright yellow. Of that. So let's now get it stood upright in our frame, because most of the time our frames will be built like that. Just checking my messages. Yes, some of you may have noticed a bit of a haircut. Ready for Christmas. Let us do. Oops, where am I going? Over here. Right. So now we've got that. So because we've had to build it flat, because that's kind of where all the shapes generate, we now need to work out how to move it. And there's an operator for moving geometry, which is the simplest thing to do. Funnily enough, called move. Here. And what we're going to do for this shape, we've got the bounds we've created it in is our from, and our to is going to be flipped round or reoriented. So let's do that. Let's generate a reoriented frame here. This is our input, and we're going to just rotate it on X, probably the wrong way. We're going from that position to that position. The defaults to stretch are fine. We're not really stretching because they're both. Here we are stretching because they are different sizes. Okay, I need to think about that. We'll see what happens. Let's plug that in here. Right, so that's brought that up there. It has, as I thought it might, shrunken it slightly. That's interesting. So we need to make sure that the thickness, no. We need to, because if we now do that, oh God, that's horrendous. We are not working. This is not working. It shouldn't squash and stretch. It should not do that. So that's partly a problem with the Oh, I wonder if it's better to just no. Okay. The path we want. The curve. We really need to let me have a look. Have I got a thing for that? Shape move. Yes. So I should move the vertices of the path, not the results of the loft. That makes more sense. Let's put that back down there. We're back down to here, and what we're going to need to do is that. Oops. So that one is move the curve from there to there, which we can do here. There we go. That's better. Now the loft happens after the points are moved. Splendid. I'm going to shift this over as well slightly, which I can do by if I offset this by half. Offset this by half in Z. Yeah, in Z. Because it's proportional, that'll then center it. So now we have our cable hanging in our frame, and if we change the height, we've got a shallower hang, and the thickness doesn't make any difference. Reduce that down a bit. Oh, maybe the thickness would be the cable thickness. Could use that. I mean, we've got it expressed separately here, but we could just take the thickness of the box. Might be nicer. Let's do that. We'll take out that input, and then we can use all three of the input dimensions, and that's going to be the Y. So let's do size. Yeah. Okay. And we don't need that input. Okay. Let's do that. So now we have our cube. We can. Don't. Let me think. No, there isn't an end cap, unfortunately. There's a feature request for that. You can't end cap them easily. But for the cables, it'll be fine. We'll just stuff them into the ceiling a bit, and then you won't be able to see them. So yeah, so that's now a little cabley thing. We can position, looks reasonable. And obviously we'll be building downwards, so even though the height is so, we'll just extend down as we need to. Okay, that's one part. I think a couple of things that would be nice. One is that if the ends met square, so there's a slight fall off. We'll deal with that later, actually. Not critical. If we have a series of them in a row and they're like fixed at intervals, you would expect the cable to sort of ride in slightly with the curve. I'll deal with that later. It's really just for a distance effect, not for up close scrutiny. I don't expect they'll all be yellow either. Mostly be black. We'll also look at how we can bundle them perhaps? Maybe? Don't know. We might just overlay them randomly and be done with that. What? I guess that's kind of... that's an interesting idea. I will experiment with that later, because we could have it where it stacks them beside each other with slightly varied parameters for bundles. We can have a look at that. And then we also probably want to be able to have runs, so that you have like several chained together. So we'll have a version of this that splits it into parts. Ooh, let's do that now. Okay, let's do the. So we've got single cable. We don't need that or that really. So that's our cable. We can reuse this to do the looped one. Let's go back to decoration. Let's add cable run. Oh, that's like a sequence of these loops. So what that will be is a case of, how are we going to do this? I'm going to use the stacker and splitter. Let's call this cable run repeat, and we'll put the stacker and the merger in. So you may have seen these before. This is some really powerful helper utilities, and we're going to use to split up the space. Be the object, and we will yeah, and then that repeat gets recursed. Spacing that one. Also got colour, which we'll pull through as well because we want them all the same colour. Right, that should be enough. And then in the outer, yeah. So the repeat is the inner one. This is the actual one. Because it's handy just to have some of the setup out here. But we will have spacing and color exposed so that we can now, let's have thing ought to be like 1, let's do 5. Okay, if I change this to, nope, not that one, that one. Why has that not done anything? Spacing. We are not repeating. What have I missed? Oh, I've connected them to the same one. Go. Frame and select. Okay. Yeah, there we go. A bit of colour. Let's go with greeny, dark greeny. Here we go. There we go. That's now quite neat. And then as we expand it, there'll be more of them. Oops, don't need to change the thickness. Lower loops like so. And we can now change the spacing as well. So we've got lots of small loops. Oh, running out of something. Like so. Right. We now have our cable procedures we can start using. Now the question then is, where do we put them? Let's get a ceiling out and decide. I could actually add it to the actual ceiling. So what we're gonna do is, no, not here. I need to bring out a Oh, it was a floor, wasn't it? From floor grid. Is it that one? No, because that's not. What are these? We've got some of these. What are they? Floor filler. That's what we want. That one. Room. Oh, floor filler. Here we go. There is a floor section. And we're actually doing ceiling. And we want to flip it over. So I'm going to do that because we've been working underneath. Obviously, it's not quite as clear what's going on, but we'll see. I mean, we could work the other way up, but that would look weird because they'd be sticking up. But we'll be fine. Let's just generate some ceiling. Let's make it a bit bigger. Okay. So what we need to do with the ceiling is decide where cables are going. Now, an obvious choice is along the joins between these things. We could have straight runs along some straight joins. Depends on the pieces. Maybe it's the edges of some of these pieces, because that we need for a long run. We need to know that they're connected, which is not always that straightforward. Sometimes it might not matter. We might just want random. We could just go from between random points and see what it looks like. Be a bit chaotic, but might work. We're going to be very chaotic. We could certainly do it on a. You could generate random points on a grid and lines, and it would be because these are like, you know, unit grid based, and you might get some weird connection points. But then we could also have straight runs as a kind of constraint. I think we start with random and go from there, really. So we're going to want basically quantity or maybe density of cables. See how we go. Right, we are looking at floor filler here. If it's a ceiling, certain things change. We basically want, if there's a ceiling, we switch on this feature, and it's going to be some sort of cable. Let's call it cable grid. Random cables over an area, e.g. ceiling. Do that. That's going to be. Let's just do the usual thing. We've got something to hook up. So in here, in this ceiling, we want to be able to, if there's a ceiling, we're going to add this thing. So we conditional seg. Where are we going to put this? It needs to be added to the output here. Oh, hang on. That's fine. Oh no, we've got recursion going on. We can't do it at this level. I think we need to bring it out as ceiling. So we've got floor filler, which we'll use, but because that recurses, we need to wrap it. Floor that can be used as ceiling. Because that has special functionality. It's going to have some filler in it, which is the same thing here. We know it's a ceiling. That'll switch the assets, and then we're going to do cable grid as well over that same base, kind of. We'll sort that out in a minute. And we need to combine them together. We're going to have some merging going on. Stick those in. So this is now our test. We don't want floor filler. We want ceiling. Maybe we do the flip already. Let's do that as well. Do that as well. So I don't need to. So and take out the rotation. Yeah, so that now gives us, builds a ceiling in the top of our shape. Let's make it room height. There we go. Oh, no, let's go back down. Okay, so that's now that. We're drawing a frame because that's what our procedure does at the moment. This cable grid just shows a frame. Now we can ceiling, cable grid, let's do cable grid, place a cable, and then we'll repeatedly do that a number of times. We'll do one here for like that. We could end up making a mess, but we'll give it a go and see. Right, let's look. So place going to be randomly choose. Well, there's different logic. Let's do some sub procedures. Completely random placement. Then we can delegate appropriately. So random. It's going to be take a frame. We need to pick 2 points, which we can do fairly easily using. How are we going to do that? Yeah, that's fine. So we'll go frame to world. So generate a point within our frame. It's going to be a random point. We'll come to that in a minute. We can use proportion because it just needs to be 0 to 1 between it anywhere in here. Random. We're going to do a random x and y. Speed from 0 to 1. We're going to make those into an x and y point. So that's our random point. That's one of our random points, but we need 2. For now, we'll just duplicate that and feed that from there. So we get 2 random points, and we need to build between them. Have we got a frame? No, we haven't. So something I've built before a number of times is a utility to build a frame between 2 points. It's useful if you've got, like, if you're following a polygon, like a perimeter, you can build frames along each edge, and then you can throw a wall procedure or something in there. So I haven't got one in here because we haven't needed that. Our rooms have been rectangular, so I might knock up that because that's quite a useful utility. I do one in here called, and I'm going to call it between XY. Build a frame between 2 points in XY plane. And because it hasn't, we're only going to use it in that orientation, or if we needed it in a different orientation, we could reorient it. It's a little fiddly to do. Basically, you've got the vector between the 2 points is your along, which I normally do x maybe, and then your y for the frame is going to be 90 degrees to that, and then your z is going to be some. There isn't really. It's going to be upwards, and we just start with use 1 because we haven't got that as a parameter, unless we want that as a parameter. And then use those. Having generated those axes, we can build a frame from that, which I'll show you in a minute. So we need. There's a couple of things we'll need to do. Let me look at those. I'm going to do a little. No, it's going to be left, isn't it? Y. No, actually, Z. Oops, can't type Z. And a vector 90 degrees This is a useful little utility again, which I'll do here. We'll need to generate the perpendicular vector. I'm going to do this. Get my axes out. So for a given x, I want to go like 90s left, and what that usually means is that the y of the new value is the x the old, so it's like near one, they're both reduced as you turn. So the y is the x, and the new x is actually a negative version of the current y. So we can do some of that. Little hack. Generate a rotated version, and we'll leave z as the same, because we are not changing anything in z. So that's our. Oops, I've done it in the wrong place. Wait a minute. Yeah, there you go. Let's do it like that. Okay. In between. Don't need that. Right. So we've got. So a frame is made from 3 unit vectors for the axes. Like this. Plus a size, plus an origin, which is where the corner is. And we can build that up from scratch with all the frame operators. There is a axes, so we can force a frame to have a particular orientation, effectively, and we're going to do that by our. We've got 2 points, so we need to do that. I don't know why. Oh, I don't need that output, do I? So actually, we've got going to have 2 inputs here. Our 2 vectors. One of them will be our origin. We'll sort that out in a minute. The other one is effectively the distance and length of the frame. Sorry, the orientation and length of the frame. But to be an axis, we need to be unit length, and so we need to normalize it, and we can do that with normalize. So if we take, but we also need a difference. So b minus a. So this is our direction vector. This is it normalized. So this is now our x-axis here. Our y-axis is going to be the result of turning this 90 degrees. We do also, for this to work, we need to also make sure there's no z component. Because that will affect the results. We might need to ignore that for now. No, I'm going to do a little tiny helper here called set z. Just a little helper. And that. So we can copy across the x and the y, and the z will come in from outside. Vector and our z, and this is our vector. This is our modified vector. Right, that's cool. We can now do this to force z to be 0 for this relation. The difference, and that's normalized. We've rotated it left, and that is our y, anti-clockwise, and z is always going to point vertically, so we'll leave that like so. This will generate a frame with the the right orientation, we need to start with a we need to do the size and the origin. So we'll do that by starting with a corner frame, offsetting it, and resizing it. So the offset is going to give us our origin, which we said was where we started, which is A. So that's going to be A units and E in world space. And then the size is going to be, we want the X size to be the length here, so it fully reaches the B point. And the Y and the Z we'll decide on in a minute, but we're going to need to make a new vector for that. So we're going to size units against the lower edge, I think. Yep. So that we use various things with that. So X is going to be the length of our A to B. Y, the thickness, I think I'm going to set to 0. We'll come back to that in a minute, because it's going to sit along the line of A and B. There isn't really a thickness. What we might do is then scale it up to be even either side, but we'll come to that in a minute. Z, I will set to 1 just so that we can see something. At the 0 might mean we can't see something, but we'll do that as a shrink so that it's symmetrical around Y. And this is going to be our thickness. Do we need a thickness as a value? No, let's just set it to 1 for now. And it's in Y. Then we apply our orientation, and that's our result. That should be what's needed. I will have a look at that in a minute. Place random is going to do frame between. We'll start by just drawing a box through a box. Color, and then place. Well, we've only got the random placement, so we'll do that first. Place random where that's the bounds and the seed, and then we need to do grid repeat. So here we're going to be we need to iterate for a quantity. We're just going to do it at the count of them. So we're going to do while our quantity is greater than 0, we're going to add stuff. It's going to be our content, which is our randomly placed, or our placed frames. That's where we're placing. That's our seed. Merge 2 because we're going to recurse. That's good, and then we need to recurse. Means output there. Frame is the same. Seed. We're not gonna be able. I want to pass it all the way out. No, I can't be bothered. What I'm gonna do is just twist it. Get a new seed. We also need to reduce the quantity by 1 so that each iteration we count down. Here, we take off 1. That's our recursion. Quantity, let's just default that to 1. That. Okay, so that's repeating. And cable grid repeat. Put that in here and see what we get. Okay, look at that. That's taken, there's one cable between 2 random points, and it's built a frame within that. And the result, the frame is then 1 by 1. That's good. And if we up this quantity, we get more of them. randomly positioned between points. Okay, so we grid table, grid place random. Let's put a cable run instead. See what we get. Da, 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 da. Okay, it's it's super thick. Super thick because it's using the 1. The spacing is probably a bit much. Let's do it, space it out a bit. And now to create, maybe we do need to specify the thickness here as a parameter. That'll probably work better. And here we can specify the thickness. Okay, a couple of things going on here. It's building, they're stuffed right up into the top, whereas I think we actually do have a thickness, which I think is like 0.25, so we should probably just split that off. Ceiling, split, nope. Split, we'd split off 0.25 top in Z, build the cables in the remainder. Nope, not the remainder. Frame, there we go. No, that hasn't helped. Why has that not helped? The remainder, Z units 0.25. That's not changed anything. I wonder why. Oh, we're not using the actual, because we're building between points. I think we would probably want to just offset it, I think in that case, not split. That makes sense. Oh. Yes. So the height of the height out here is 1. We need to resize this to be same. Okay, so we've gone from the actual frame into coordinates, and we're building between those, making assumptions about where the Z is. I think we need to use the Z from here. Offset. No, we are using that Z. Okay. We're resizing to 1 though. We don't have that information. That's not this. Width. Let's bring out the height as well. Let's do that. Then we can specify that the height is the height of the input frame. Okay, so now if we put this to 0.25, we get better. All right, yeah, it's kind of looking cool. Does it mean if we change that? Yes, so that now uses the actual ceiling space. Maybe not quite what we want. I'm going to go with that. I'll make them black. They're not quite full black. Maybe we need to vary that colour a little. Let's do a random blend between white. We will not go fully to white. Okay, now let's do some variation in thickness and height. Frame to width. So that width is used as our thickness. Spacing to change as well. Color. Do thickness between 0.05 and 0.2. See what we get there. There we go. Some different thicknesses of cables. And next thing to do is color. Spacing, let's do that as random as well. Oh, hang on, we should chain these. They'll become dependent. Spacing, let's go with 1 meter to 4 meters. Fine, no, 1 is too short, don't like 1, let's do 2 to 5. So sometimes they're long, sometimes they're not. And we also need to currently we are building from 0 up. If we exaggerate it a bit so I can see that, in order to set the height of the droop of the cable, it needs to be scaled from the top, which we can actually do with another split. Split here. Let's split this frame. Oh no, hang on. This frame. If we split this frame before the cable run, it'll be the remainder. Z proportion. Around is that. Yeah, so that's kind of backwards. So that's now our droop value, which we can also randomize. And we're going to have a droop. It's proportion, it's like between 0 and 1. Maybe we should do units. We can specify it quite explicitly. Let's go 10 centimeters for a very short. Oh no, we're randomizing. We're going from about 10 centimeters for a very tight cable to a very half a meter for like a dangle. Maybe more than half. Let's go 1. So, okay. Now I think that's pretty good. I don't really care that it's a bit chaotic. Could be shinier. They could not intersect the ceiling as much. It's looking cool. Feed is not being fed in. Let's fix that. Ceiling. Grid. Feed. That. Quantity we'll talk about in a minute. Ceiling. Just use the same feed. That's fine. Now we can have different ceilings with different cable configurations. So let us play with the light in. This is a bit easier to see what's going on. Okay, we've got some cables. What I want to do. Right, quantity. We are maxing out because I think if I secret feature, if I look in here, out of modeling memory, yeah, so we're running short of triangles. I haven't got it set very high on this project, so 100 meg. Oh, I've turned it down recently, that's why I'm not generating a huge amount. But what we'll find, what we might see, is if I switch to wireframe, these are incredibly detailed cables at the moment. We do not need that amount of detail for cables, so let's fix that next. Where we have our cable, our loft, and our curve. So the curve, which is our cross section, that's particularly high. Let's deal with that first. So the values we can fiddle with. Hang on. Back to that. The values we can fiddle with for this are the steps and the curve. So curve is to do with enough steps to ensure that the step angle is not more than that amount. So we can increase that a bit. But we're also insisting that at least 12 steps are used, which we cannot reduce. So we'll turn that down as well. Oh, hang on. Why is that affecting that? Oh, sorry, this is the I should be doing the ellipse. So the ellipse, yes. So we'll turn that down. So we're less bothered about the angle change. In fact, for cables, it's probably fine just to say fully controlled here. So we don't want like 6. Let's try 8. Because they are smoothed. You can specify that here. Smoothing angle 15 degrees should be enough. We'll check that in a minute when we're back to the other view. Sorry, the curve here. This is the similar thing. This is the. Now this is probably better done as an angle control because the tighter bits will need more detail. You can see here it's slightly bigger curve. It uses more pieces than here. Now that's allowed us to already have more cables. Go back to here. Okay, so the smoothing, the shape smoothing is not enough. It's gone all angular. Let's fix that next. So that is on our loft and our shape flag. Our smoothing is 15 degrees. We've obviously exceeded that, so we can turn this down a bit or up a bit until it clicks in. Let's just put it up to maximum because we always want it smoothed. We've got a seam. I can't remember what the fix for the seam is. I think. Let me have a look. Shape closed. There you go. That improves it a little bit. That'll do for now. So back to here. Okay, we now have more cables because we've lowered the quality of them. Let's go with that and see if we can up the amount even more. Yeah. If we really want the cables, we can go to town. Okay, I think that'll do for the minute. I'm just going to leave that at like 50 cables. Sure. And let's see what it's done to our. Oh no. So this is the new procedure with the ceiling up thing. We haven't used that in the room yet. The room still uses the floor upside down. So Okay, let us go for, where's the room? Room main. Our main room. So yeah, floor, ceiling here. If the ceiling's enabled, we have ceiling, and we do the reorient. We don't need that anymore because that's now part of the ceiling. There's a ceiling here. We can hook this up instead, like so. Yeah, it's fairly obvious, but we'll say it anyway. Ceiling, we don't need that. Okay. Let's go and see what was done to our rooms. There we go. We have cables. That's a bit excessive. Sure. Quite like it though. They're quite cool. Let's go with that. Why are we chugging? Hello? Liking that. Let's go big. Here we go. Cables. That'll do. Noodles. We have space noodles for Christmas. And I'm going to leave it at that, I think. Have a good Christmas. Take care. See you in the new year.